Hello students, this is lecture number 10. In the previous lecture, we saw how to solve the system of linear equation using adjoint method. In this lecture, we will study how to solve the system using the Cramers rule. So basically, in this lecture, we will study what is the Cramers rule and how to solve the system using the Cramers rule. Okay, so firstly, we will see the Cramers rule for the system having two equations and two unknowns. Okay, so this will be the system having two equations and two unknowns. Okay, so for that I will consider one system of linear equation. Consider one system of linear equation a1x plus b1y equal to c1, a2x plus b2y is equal to c2. Instead of c1 and c2, I will take this as d1 and d2. Okay, so this is d1 and this is d2. So this system contains two equations and two unknowns. Okay, so we need to solve this system, means to find the values for x and y. Okay, solve means what? To find values for unknowns. And what are the unknowns? That is x and y. Okay, so in this case, the value for x by Cramers rule, therefore by Cramers rule, x will be dx by d and this y will be dy by d. Okay, where this d is the determinant. Okay, and this determinant will contain the coefficient of x and y. Okay, so what we will see here, this will be a1, a2, b1, b2. Okay, and this dx is what? It is again the determinant. Okay, but instead of a1 and a2, there will be d1 and d2. Okay, and same as b1, b2. Okay, and this dy. Okay, in this determinant there will be a1 and a2, but instead of coefficient of y, there will be d1 and d2. Okay, so using these two equations for x and for y, we can easily solve the system of linear equation which contains two equations and two unknowns using Cramers rules. Okay, for example, suppose we have this system of linear equation 7x minus 2y equal to 4 and x plus y equal to 3. So this is our system which contains two equations and two unknowns. Okay, and we need to solve this given system. Okay, means to find the values for x and y. Okay, so obviously by Cramers rules, by Cramers rule, this x will be dx upon capital D and this y will be dy upon capital D. Okay, where this capital D is what? The coefficient of x and y. Okay, so this will be 7, 1, minus 2, 1. Okay, and after solving this will be 7 into 1, 7, minus plus, this will be 2, so which is equal to 9. Okay, so we got the capital D is equal to 9. Also, we will try and find the value for this dx. Okay, so this dx is what? Again, instead of coefficient of this x, okay, what we will do? We will replace it by the d1 and d2, and in this case d1 and d2 was 4 and 3, and the coefficient of y will be as it is. Okay, so solving this determinant, this will be 4 plus 6, which is equal to 10. Okay, so we got the value for dx, which is equal to 10. Also we can find this value for dy. So in this dy, instead of coefficient of y, we will write d1 and d2, which are 4 and 3, and the coefficient of x, 7 and 1 will be as it is. So this will be 21 minus 4, which is equal to 17. Okay, so we got all the values, so that we can easily find now the value for x. Okay, therefore x is what? Dx upon capital D. Okay, so what is dx? Dx is 10 and capital D is 9. So value for x is 10 by 9, and this y will be the dy upon capital D. The value for dy is 17 and the capital D is 9. So value for y will be 17 by 9. Okay, so this is how we can solve the system which contains two equations and two unknowns. Okay, now we will see the second method when the equation contains, or the system contains three equations. Okay, three equations and also three unknowns. Okay, so suppose we have one system like a1x plus b1y plus c1z equal to, suppose d1. This is a2x plus b2y plus c2z is equal to d2. Then a3x plus b3y plus c3z is equal to, suppose, d3. Okay, so obviously this system contains three equations and three unknowns. Okay, then we can solve this system by Cramers rule. Okay, we will solve it, means what? We will find the values for x, y and z, and by Cramers rule the values for x, y and z are given as x is equal to dx upon capital D, y is equal to dy upon capital D, and this z is equal to dz upon capital D. Okay, where this capital D is the determinant of the coefficient of x, y and z. Okay, so this will be a1, b1, a1, a2 and a3. Okay, second column will be b1, b2 and b3. Third column will be c1, c2 and c3. Okay, dx. Okay, so what will be dx? Dx will be, again it will be the determinant, but instead of the coefficient of x, this determinant will contain this column as d1, d2, d3, and the remaining terms will be as it is, like b1, b2, b3, c1, c2, c3. Similarly, we can find this dy. This will be again the determinant. So in this case also, instead of coefficient of y, there will be d1, d2, d3, and the remaining terms will be as it is, as a1, a2, a3, and this will be c1, c2, c3. Okay, also we can find this dz. It will be again the determinant. So in this case also, instead of the coefficient of z, there will be d1, d2, d3, and the remaining term will be as it is. Okay, b1, b2 and b3. Okay, so if you will calculate the values for d, dx, dy and dz, you will easily get the value for x, y and z. Okay, so for this we will see one example. Okay, to solve this system of linear equation which contains three equations and three unknowns using the Cramers rule. Okay, so by Cramers rule, okay, so by Cramers rule, what says Cramers rule? X is equal to dx upon capital D, y equal to dy upon capital D, and z equal to dz upon capital D. Okay, where this capital D is the determinant, it will be determinant of the coefficient. Okay, the coefficient are 1, 2, 1, minus 1, 1, 1, then 1, minus 3, 1. Okay, so solving this determinant, okay, so this will be 1 into 1 plus 3, okay, minus minus plus 1 into 2 plus 3, okay, plus 1 into, this will be 2 minus 1. Okay, so this will be 4 plus 5 plus 1, which is equal to 10. Okay, so once you will get the value for D, you will calculate the value for dx. Okay, so here this dx is what? Again, instead of coefficient of x, you just need to write the values for d1, d2 and d3, and the values for d1, d2, d3 are 4, 0, 2, and the remaining terms will be, means the coefficient of y will be minus 1, 1, 1, and this is 1, minus 3 and 1. Okay, now solving this determinant, this will be 4 into 1 plus 3 plus 1 into 0 plus 6, okay, plus 1 into 0 minus 2. So this will be 4 into 4, that is 16. This will be 0 plus 6 is 6 into 1 is 6. This will be minus 2. Okay, so this will be 16 plus 4, which is equal to 20. Okay, so we got the value for dx. Okay, now we will get the value for dy. Okay, so dy will be again the determinant. Okay, but in dy, instead of the coefficient of y, we will write d1, d2, d3. So this will be 4, 0, 2, and the remaining term, that the coefficient of x will be as it is and the coefficient of z will be as it is. Okay, so solving this determinant, this will be 1 into 0 plus 6, then minus 4 into 2 plus 3, okay, then plus 1 into 4 minus 0. Okay, solving this, this will be 0 plus 6, that is 6 into 1 is 6. This will be 2 plus 3 is 5 into 4 minus 20, and this will be plus 4. Okay, so this will be 10 minus 20, which is minus 10. Okay, so we got the value for dy. Okay, so on the next page we will try and find the value for dz. Okay, and this dz is what? It is again the determinant. Okay, but in this determinant, instead of the coefficient of z, we will write the d1, d2, d3, which are 4, 0 and 2. So this is 4, 0, 2, and the remaining term will be as it is. So this is 1, 2, 1. Okay, this is 1, 2, 1, and this will be minus 1, 1, 1, minus 1, 1, 1. So let's find out this determinant. This will be 1 into 2 minus 0 plus 1 into 4 minus 0. Okay, this is 0. Okay, this will be 4 minus 0, then this will be 4 into 2 minus 1. Okay, so this will be 4, 2 plus 4 plus 4, which is equal to 10. Okay, so finally we have got all the values for d, dx, dy. So we got d equal to 10, dx equal to 20, dx equal to 20, dy equal to minus 10, and dz equal to 10. Okay, so final answer, we will get the value for x, which is dx by d, which is 20 by 10, which is 2. Okay, we will get y as dy by d. Okay, dy is minus 10 by 10, this will be minus 1, and finally we will get this z, which is dz by d. Dz is 10, d is 10, so answer is 1. So we got all the values for x, y and z which will satisfy the given system of linear equations. Suppose we have the next example, okay, to solve this system of linear equation using Cramers rule. Okay, so firstly, by Cramers rule, we need to get the value for x, y and z. So we know x is what? Dx by d, y is what? Dy by d, and this z is what? Dz by d, where this capital D is nothing but the coefficient of the given variables. Okay, now you know this system contains 3 equations and 3 variables. Okay, this contains 3 equations and 3 variables x, y and z. Okay, so in the first equation the coefficient of x is 2, in the second equation coefficient of x is 0, in third equation the coefficient of x is 3, right? In the second column the coefficient of y in the first equation is 3, the coefficient of y in the second equation is 1, the coefficient of y in the third equation is 0. Okay, in the third column the coefficient of z in the first equation is 0, the coefficient of z in the second equation is -3, and the coefficient of z in the third equation is 1. Okay, so solving this determinant. Okay, so after solving, okay, so we'll solve this determinant, okay, which will be 2 into 1 plus 0, okay, minus 3 into 0 plus 9, okay, and plus 0, which will be 2, and this will be minus 27, which is minus 25. So we got the value for capital D. Okay, now we need this dx. Okay, what is this dx? Dx is again the determinant, but instead of the coefficient of x we will write the values for the constants d1, d2 and d3. So this will be 5, minus 2 and 4, and the remaining determinant will be as it is. Okay, 3, 1, 0, 0, minus 3 and 1. So solving this determinant, this will be 5 into 1 plus 0 minus 3 into minus 2 plus 12. Okay, so this will be 5 minus 3 into 10. Okay, so this will be 3 into minus 2 plus 12, this will be 10, right? So this will be 5 minus 30, which is again minus 25. Okay, so we got the value for dx, which is minus 25. Okay, in the next thing we need this dy. Okay, so we'll forward this dx from the previous term. Okay, so what is d? D is this. Okay, so we'll take it to the next page. Okay, what we need this dy. Okay, so in dy also, instead of the coefficient of y we will write the d1, d2 and d3, okay, which are 5, minus 2 and 4. So this will be 5, minus 2, 4, and the remaining term 2, 0, 3, and this term 0, minus 3 and 1 will be as it is. This will be 2 into minus 2 plus 12 minus 5 into 0 plus 9. Okay, so this will be 10 into 2, 20, this will be minus 45, which is minus 25. Okay, similarly we can calculate the value for dz. Okay, so again this will be determinant, but instead of the coefficient of z there will be the constant 5, minus 2 and 4, and the remaining terms will be as it is. Okay, so this is 3, 1, 0. Okay, solving this determinant again, this will be 2 into 4 minus 0 minus 3 into 0 plus 6. Okay, and plus 5 into 0 minus 3. Okay, so this will be 8, this will be minus 18, and this will be minus 15. Okay, so this will be minus 10 minus 15, which is minus 25. Okay, so we got all the values for d, which is d is 20 minus 25, dx is minus 25. Okay, this is minus 25, dx is minus 25, dy is minus 25, and also dz is minus 25. So finally our final answer, x will be dx upon d. Okay, so dx is minus 25 upon d is minus 25, so answer is 1. dy, y will be dy by d. Okay, so this will be minus 25 upon minus 25, which is 1, and also this z, which is dz upon d, which is minus 25 upon minus 25, which is again 1. So we got all the values for x, y and z, which will satisfy the given system of linear equation. Okay, so similarly we have this example. To solve this example using Cramers rule, so firstly we will write this system into the standard form. Okay, means what, all the variables will be to one side and all the constants will be to the other side. Okay, so finally we will get the system like this: x plus y plus z is equal to 4. Okay, and this will be 2x plus y plus z is equal to 1, and this will be x plus minus y, x minus y plus z is equal to 0. Okay, so this is in the standard form, and we will solve this system. So by Cramers rule, okay, this x is what, dx upon d. Okay, y is what, dy upon d, and z is what, dz upon d. Okay, where this d is the determinant of the coefficient of x, y, z. So this will be 1 2 1, 1 1 minus 1, 1 1 1. So solving this determinant, this will be 1 into 1 plus 1 minus 1 into 2 minus 1 plus 1 into minus 2 minus 1. Okay, so this will be 2, this will be minus 1, and this will be minus 3. So this will be 2 minus 4, which is minus 2. Okay, now next thing is to find the value for dx. Okay, so dx will be, dx is the determinant, but instead of the coefficient of x we will write the constant as 4 1 and 0, and the remaining terms will be as it is 1 1 minus 1 1 1 1 1. Okay, so this will be 4 into 1 plus 1, okay, minus 1 into 1 minus 0, and plus 1 into minus 1 minus 0. Okay, so this will be 2 into 4, that is 8, 1 into minus 1 minus 1, this will minus 1 into 1 is minus 1, so this will be 6. Okay, this is 8. Okay, similarly we can find this dy. Dy is again the determinant, but instead of the coefficient of y we will write the constant 4 1 0, and the remaining terms will be as it is. Okay, so this will be 1 1 1. Solving this, this will be 1 1 minus 0 minus 4 into 2 minus 1 plus 1 into 0 minus 1. Okay, so this will be 1, this will be minus 4, this will be minus 1, so answer is minus 4. Okay, similar way we can calculate this dz. Okay, so again instead of the coefficient of z we will write the constants d1 d2 d3, which are 4 1 and 0. Okay, so write it here 4 1 0, and the remaining terms will be as it is, a 1 2 1 and 1 1 minus 1 1 1 minus 1. So this will be 1 into 0 plus 1 minus 1 into 0 minus 1 plus 4 into minus 2 minus 1. So this will be 1, this will be plus 1, and this will be minus 12. Okay, this is what? Minus 12. So this is 2 minus 12, which is minus 10. Okay, so finally we got all the values for dx, dy, dz, and also d. Okay, we calculated d. D is minus 2, dx is 6, dy is minus 4. Minus 2, dx is 6, dy is minus 4. Okay, and dx dz is minus 10. Okay, so by Cramers rule, okay, therefore by Cramers rule, okay, what we will get, x is equal to dx upon d, which is 6 upon minus 2, which is minus 3. Okay, y is equal to dy upon d. Okay, dy is minus 4 upon d, which is 2, and this z is equal to dz upon d. Okay, dz is minus 10 upon d minus 2, which is 5. So we got the solution for the given system of linear equation. Okay, now in this example, again we will try and solve the given system of linear equation. Okay, this is for assignment. Okay, you solve it at home. Okay, and check your answer by putting in equation number 1, 2 or 3. Okay, you will see whether your answers are correct or not. Okay, I will solve this system. Okay, this is the system which contains these terms: x plus z equal to 4, y plus z is equal to 2, and x plus y is equal to 0. Okay, so okay, let me check whether I have solved this or not. Okay, no, it is not solved. Okay, so we'll solve this system. Okay, so firstly, by Cramers rule, okay, by Cramers rule, what will be x? X will be dx by capital D, y will be dy by capital D, z will be dz by capital D. Okay, where this capital D is the determinant of coefficient of x, y and z. Okay, so if you'll see, the coefficient of x in first row is 1, in second row it is 0, in third row it is 1. Okay, in the next term, the coefficient of y in first row is 0, in first row it is 0, in second row it is 1, in third row it is 1. Okay, next term, the coefficient of z in first row is 1, second row it is 1, in third row it is 0. Okay, so let's solve this determinant. This will be 1 into 0 minus 1. Okay, then minus 0 into, okay, this term will be 0, plus 1 into 0 minus 1. Okay, so this will be minus 1 plus minus 0 or plus 0, and this will be minus 1, which is minus 2. Okay, so we got the value for capital D. Okay, now we will calculate the value for dx. Okay, so this will be again the determinant, but instead of the coefficient of x, we will get the coefficient of the constants. Okay, 4, 2 and 0, and the remaining terms will be as it is. Okay, 1, 1, 0. Okay, solving this determinant, this will be 4 into 0 minus 1, the second term will be 0, and third term 1 into, okay, this will be 2 minus 1. Okay, so this will be minus 4. Okay, and this is 2 minus 1 means 2, so this will be plus 1, that is minus 3. Okay, similar way we can calculate this dy. Dy will be again the determinant, but instead of the coefficient of y, we will write the constant 4, 2, 0, and the remaining terms will be as it is. Okay, so 1, 1, 0. Solving this determinant, this will be 1 into 0 minus 0. Okay, then minus 4 into 0 minus 1 plus 1 into 0 minus 2. Okay, solving this, this will be 0, this will be minus 1 into minus 4 plus 4, this will be minus 2, which is equal to 2. Similarly, we can calculate this dz. It is again the determinant, but instead of the coefficient of z, we will write the d1, d2, d3, and the remaining columns will be as it is. Okay, 0 1 1, so this will be 1 into 0 minus 2 plus 0 second term plus 4 into 0 minus 1, so this will be minus 2 plus 0 minus 4, which is what, minus 6. Okay, so we got the values for dx, dy and dz. Okay, so we got d equal to minus 2, okay, dx, dy and dz. Okay, so dx is minus 3, 2 and minus 6, so this is what, minus 3, 2 and 6, minus 6. Okay, so finally we will get this x is equal to dx upon d is equal to, dx is minus 3 upon d is minus 2, so which is 3 by 2. This y is dy upon d, so dy is 2 upon minus 2, which is minus 1. Z equal to dz upon d, so this will be minus 6 upon minus 2, which is equal to 3, and so that we will get the values for the variables x, y and z, which will satisfy the given system of linear equations. Thank you. That was the Cramers rule.